Hello. Today we are going to treat Model 2 of CCNA7 Level 1, Introduction to Networks. And my name is Kwame Enimapia. I'm a Cisco Certified Academy Instructor. And I'm with Kwaps Networks Training Academy, Ghana. Now, this discussion today is going to be an introduction to a more theoretical explanation, and this will follow with a lab activity that is going to really explain what we have discussed. Now, the model title is Basic Switch and End Device Configurations. And the objective is to implement initial settings including passwords, internet protocol addressing, and default gateway parameters on a network switch and end devices. We are going to discuss the Cisco IOS access. Now, Cisco has an operating system on all its devices. The switch and the router mainly run what we call the Internetwork Operating System, and simply call the iOS. And we're going to explain we're going to also explain how to navigate the Cisco Internetwork Operating System to configure network devices. We are going to also learn the command structure by describing the command structure of the Cisco iOS software. And then we are also going to look at the basic device configuration by configuring the Cisco iOS devices with the command line interface. And then we are going to save the configurations by using the iOS commands to save the running configurations. We are also going to explain how devices communicate across network media, and we are also going to configure the IP address or the IP addressing on a host. We also verify connectivity between two end devices. Cisco Internetwork Operating System access. Now, the Cisco iOS operating system has a shell, and every operating system also has a shell. Now, the shell is the user interface that allows users to request specific tasks from the computer. Now, these requests can be made either through a command line or a graphical user interface. Now, the differences between a command line interface and a graphical user interface is that the command line interface has to do with giving commands to an operating system using strings, characters, and words. Those kind of command line operating systems or command line inputs do not have pictorial demonstrations, but the graphical user interface, as the name implies, gives you a graphical demonstration or output that helps the user to interact with the system. So the requests that the request for specific tasks can be made through either a command line or graphical user interface. So this is the user interface, and the first point of interface, or the first point of communication with the operating system, has to do with the shell. And then the kernel communicates between the hardware and the software of a computer and manages how hardware resources are used to meet software requirements. Then the hardware, which is the physical part of the computer, include the electronics. Now, a GUI allows the user to interact with the system using an environment of graphical icons, menus, and windows. So this is an example of a graphical user interface shell. Now, a GUI is more user-friendly and requires less knowledge of the underlying command structure that controls the system. Now, examples of these GUIs are the Windows operating system, the Mac or the Apple Macintosh. We also have the Linux. We have the Apple Internet Network operating system and the Android. Now, GUIs can fail. They can crash or simply not operate as specified. And for these reasons, network devices are typically accessed through the command line. Purpose of an operating system. Now, the personal computer operating system enables a user to do any of the following. 1. To use the mouse to make selections and run programs. The second thing is also to enter text and text-based commands. Now, the command line network operating system enables a technician to do the following. 1. To use a keyboard to run a command line-based network programs, or also use a keyboard to enter text and text-based commands. And the technician can also use the command line to view output on a monitor. We want to look at some access methods to the Cisco Internet Network operating system. Now, we have what we call the console. Now, the console is a port behind either a switch or a router that we use to access a device in order to provide maintenance, such as performing initial configurations. We also have an access method called the secure shell, which establishes a secure remote command line connection to a device through the virtual interface over a network. You have to take notice that this is the recommended method for remotely connecting to a device. So we call it a remote login application. We also have another access method to the operating system through what we call telnet. Now, this telnet is normally called the administrator's best friend because it establishes a remote command line, but an insecure one, connection to a device over the network. So here, user authentication, passwords, and commands are sent over the network in plain text. Now, we want to talk about terminal emulation programs. Now, these terminal emulation programs are used to connect to a network device by either a console or by a secure shell or telnet connection. There are several terminal emulation programs to choose from. The examples are the POTI, the TerraTerm, and then the Secure CRT. Now, these terminal emulation programs are normally the software that run on a particular laptop or a desktop that connects to a console port of a switch or a router. Now, this terminal emulation programs helps you have, or helps the user have interface with what? The device that is being configured, or the device that is being connected for configuration. So we have the POTI. This is an example of the POTI configuration, and these are easily downloaded on the internet. And this is what we call the TerraTerm. Any of them can be used. Now we want to look at the Internet Operating System navigation. Now, this explanation will be well understood when we have a packet tracer session where you see the prompts that are being displayed here, this router prompt and the switch prompts, and then the modes. So we will take the descriptive explanation here, and then when we move on to our packet tracer or physical devices, we can have a better understanding of what we have discussed. Now, the primary command modes for either a switch or a router are the user executable mode. The user executable mode. Now, when you enter into the switch or a router through a console port, the terminal emulation software helps you to have an interface with command modes. And the first interface you meet is, if it's a router, this is the interface you meet. And if it is a switch, this is the interface you will see. So, allows access to only a limited number of basic monitoring commands. So at this mode, at this user executable mode, you only have access to only basic monitoring commands. And is also identified by the command line interface prompt that ends with the greater sign symbol. We also have the privileged executable mode. So when we move from the user executable mode, we move next, after we have given a particular command, to the privileged executable mode. Now, this mode allows access to all commands and features identified by the command line prompt and ends with the hash sign. So, to remember, the user executable mode ends with the greater signs, the greater than sign, and then when the command is given to it, it moves to the privileged executable mode, which also displays the end with a hash sign. Now, from there we move to the global configuration mode. Now, this mode is used to access configuration options on devices. Now, we also have the line configuration mode. The global configuration mode looks like this for a switch, and if it's a router, you also see router config hash sign. And then to configure terminal lines, which we call the line configuration, here we used to configure the console, secure shell, telnet, or auxiliary access. So here, when you are in this particular mode, this is what shows at the prompt. If it's a switch, you see switch into bracket config line and a hash. And then for interface configuration mode, this is used to configure a switch port or a router interface. And this is the mode. When it is activated, you see switch config if. Now, all these things will be better envisaged in a practical session. Now, we want to look at navigation between the iOS modes. At the privilege mode, if you have to move from user executable mode to the privilege executable mode, the command to use is enable. So if it is a switch, at the switch port, when you use the enable command, it moves you straight to this prompt, switch hash, that means that you have moved from the executable mode to the privilege mode. Now, if you have to move into the global configuration mode, the next command that you use is configure terminal. So when configure terminal is typed at this point, it moves you straight from the privilege mode to the global configuration mode. And this is how the prompt will be. So from the privilege mode, you type enable, and then you have switch hash. And then to move from the privilege mode to the global configuration mode, you type configure terminal at this point. And then it moves to this point. And then if you want to configure lines to move in and out of line configuration mode, use the line command followed by the management line type. To return to the global configuration mode, use exit command. So when you type exit, it will move you to the previous mode which you found yourself. And the more you exit, the more it takes you back to the previous mode. Now, to configure the line, we have been told that the lines are used to configure console, SSH, telnet, or auxiliary. Now, if you want to secure all these things, you have to move to that mode. So, for a line configuration, the command is line console 0. Now, the reason why we give a command called line console 0 will be explained subsequently in our packet tracer practical tutorial. So when the line console command is given, it would have taken you to the line configuration mode. If you want to move from this configuration mode to the global configuration mode, you just type exit and it will move you back. If you want to move from global configuration mode to the privileged executable mode, you just type edit and it will move you back. Now we also have sub configurations mode. So to move out of any sub configuration mode, to get back to the global configuration mode, use the exit command as I have explained, or a shortcut command key Ctrl+Z. Now to move directly from the sub configuration mode to another, type in the desired sub configuration mode command line. For example, the command prompt changes from command line to command if you use the end command. So we want to look at the command structure. Now the Cisco IOS command structure has specific parameters defined in the operating system. And it also has an argument which is not predefined, but it is a value variable defined by a user. So the switch at this mode, you can type a command show IP protocol. Now this is the prompt. So on the switch, you realize that the prompt is the switch plus the greater sign, and then the show is the command, and then the space is given, and then the keyword or argument that follows the command for execution is also brought. So for example, switch, which is the prompt, takes a command ping, and then you give a space, and then you have a keyword that is the IP address. So if you want to ping an IP address at the prompt, the command will come plus space plus the keyword or argument. Now, a command might require one or more arguments. To determine the keywords and arguments required for a command, refer to the command syntax. Now, boldface text indicates commands and keywords that are entered as shown. And then italic text indicates an argument for which the user provides the value. So convention, the convention is, if the convention is boldface, the boldface text indicates commands and keywords that you enter literally as shown. If they are in italics, they indicate arguments for which you supply values. And then if the square bracket indicates, if there is a square bracket, it indicates an optional element, keyword or argument. And if they are in braces and vertical lines within square brackets, indicate a required choice within an optional element. So spaces are used to clearly delineate parts of the command. Let's look at it. The command syntax provides the pattern or format that must be used when entering a command. So the command is ping, and the user defined argument is the IP address of the destination device. So for example, ping 10.10.10.5 This is just an IP address of a particular device which you want to find connectivity. So on your machine, on your device, you type ping and then the IP address of what? That device which you want to have a connection with. So the ping plus the IP address. So the command is traceroute and the user defined argument is the IP address of the destination device. For example, traceroute 192.168.254 and 254. If the command syntax with multiple arguments, you may see it presented like this. So a switch at this mode, you have different arguments like switch port security agent, and then it has multiple arguments, either static, either time, either type, whether it's absolute or inactivity. Now we want to look at the iOS help features. Now the iOS has two forms of help available. We have the context-sensitive help and command syntax check. Now, the context-sensitive help enables you to quickly find answers to these questions. Now, which commands are available in each command mode? Which command starts with specific characters or group of characters, and which commands and keywords are available in particular commands? So at the prompt, when you type ping and then a question mark, it will give you a database of words that can be used with that command. So you either ping a particular destination address or a host name, or you either ping an IP address, or you either ping a particular version of an IP address. Now, so this is the context-sensitive help. Now, when we come to the command syntax check, this verifies that a valid command has been entered by the user. Now, if the interpreter cannot understand the command being entered, it will provide feedback by describing what is wrong with the command. So when you are typing the command and there's something wrong with the command, it will give you a checker which will tell you that it's an invalid input detected. So the help features are two. One helps you to find which command goes, or which available command goes with a particular argument. And then the command syntax check will also be there to be checking you if you are typing the wrong commands. Now we also have hotkeys and shortcuts. The command line interface for the iOS provides hotkeys and shortcuts that make configuring, monitoring, and troubleshooting easier. Now, commands and keywords can be shortened to the minimum number of characters that identify unique selections. For example, the configure command can be shortened as conf because configure is the only command that begins with conf. So some of the commands can be shortened and the system will respond. So if it's configure, you want to type configure and you do con, it will tell you it's an ambiguous command. But when you do con plus what? The question mark, it gives you a database of all words that can be used, or all commands that can be used that goes with the first three letters. So it shows you that configure it gives you that you can use a command like on configure. Now, when you type conf t, it represents configure terminal. So as soon as you enter it in the S short form, it picks it and then the command is executed. So we want to look at the keystroke and their descriptions. When you use the tab key, it completes a partial command name entry. When you use a backspace, it erases the command to the left of the cursor or the insertion pointer. When you use the left arrow or Control B, it moves the cursor into one character to the left. And then when you move the right arrow or Control F, it moves the cursor to the character to the right. Up and down arrow or Control P recalls the command in the history of the buffer. Now, when a command output produces more text than can be displayed on the terminal window, the iOS will display more. And when you press the space bar or the enter key, it will just give you the rest of the of the hidden display. So the keystroke is enter key, the space bar, or any other key. And this displays the next line. The space bar also displays the next screen. And then any other key ends displays strings returning to the privileged executable mode. And then the Control C also is used when any configuration mode ends the configuration mode and returns to the privileged executable mode. And then Control Z, when any configuration mode when in any configuration mode ends the configuration mode and returns to the privileged executable mode. And then the Control Shift +6 key is an all-purpose break sequence used to abort DNS lookups and trace routes, pings, etc. Now, if we want to go to the basic device connectivities or configurations, the first configuration command on any device is to be given a unique name. By default, all devices are assigned a factory default name. For example, a Cisco IOS switch is called a switch. And then we want to find the guidelines for naming the devices. 1, you have to start with a letter. 2, it must contain no spaces. The next thing is that it has to end with a letter or a digit. You also need to use only letters, digits, and dashes. And then you need to be less than 64 characters in length. So to return the switch to the default prompt, use the no hostname global configuration command. So here, at this prompt, right, this is the default switch name that is given to the switch. But we want to call the switch swfloor1. So as soon as we use the command hostname swfloor1, quickly it changes from the default switch to the name that we have given to it as swfloor1. So now at this prompt, this switch is called swfloor1 as given by the technician or the user and not as given by the manufacturer on purchase. Now, you need to give these devices also passwords, and you don't need to use weak or easily guessed passwords. Now, all networking devices should limit administrative access by securing their modes, either the privileged executable mode, and remote telnet access must also be given passwords. In addition, all passwords should be encrypted and legal notifications provided. We have mentioned earlier that we have telnet, we have remote login applications, we also have the console where we connect and do configurations. Now, all these terminals or line terminals must be given passwords so that unauthorized users or anybody from anywhere cannot hack into the system. And there's the need to provide passwords that are very important. And these are the guidelines. You have to use passwords that are more than 8 characters in length. You also have to use a combination of upper and lower cases, numbers, special characters, and numeric sequences. You also need to avoid using the same password for all devices. You also do not use words because they are easily guessed. So note that most of the labs in this course use simple passwords such as Cisco and class. These passwords are considered weak and easily guessable and should be avoided in production environments. The reason why we normally use Cisco and class are the fact that in the labs, when you give the passwords, they must be as guessable as possible so that the next user, the next class who also uses the lab or a packet tracer activity can also know the password and then be able to disable them and also use it for their other configurations. But in the production environment, you don't need to use guessable passwords, otherwise your system can be compromised. So to configure these passwords, you need to secure the executable mode access. So first, enter the line console configuration mode using the line console 0 command in global configuration mode. We'll do that practically and you would understand. Now next, specify the user executable mode password using the password command. And then finally, enable user executable access using the login command. So securing privileged executable mode access. Now, if you want to secure the console port, which is the line console 0 command, and give it a password, you need to declare the console port. So here at the executable mode, you need to declare the port which you are going to work on, or the interface you are going to work on. Then the interface is console. So console 0. So the command is line console 0, right? And then the next command will be password Cisco. But in a production environment, you will not use Cisco, but you will use a more technical password that people might not easily guess. And then the next command is login. And it says finally enable user executable access using the login command. And then when you say end, that means that now you have given the console port a password. Now if you want to secure the privileged executable mode access, first enter a global configuration mode. So you go to configure terminal, then you give it a secret password. And the command is enable secret plus password. So if it's the password you want to use is class for the secret password, you say enable secret class exit. That means that apart from giving the console a password, you have also given it another secret password, so that when anybody enters it, it will ask for the console password. As soon as the console password is given, automatically it also asks for the secret password. Now, the virtual terminal line access, which we call the VT1 lines, you need to secure them. And you have to first enter the VTY configuration mode using the line VTY 015 command in global configuration mode. So here, for a switch has 15 terminal lines. And these terminal lines are remote login lines, which must all be protected with passwords. When we say it's a virtual terminal line, it means that it is not a physical line where you can connect to, but remotely, it's a logical port or lines where administrators or other unauthorized users can use to have access to your switch or the router. And for the switch, it has a range between 0 and 15 terminal lines. So you declare that interface, which is line virtual terminal 0 to 15, provide a password called Cisco. So when this Cisco password is activated on all the 14 terminal lines, and then ask for the password at login, a password is given to the virtual terminal lines. So note, virtual terminal lines enable remote access using Telnet or SSH to the device. Many Cisco switches support up to 16 virtual terminal lines that are numbered 0 to 15. So to correct myself, there are 16 virtual terminal lines, which has a range between 0 and 15, and not 14 as earlier mentioned. Now, these passwords must be encrypted. Now, the startup configuration and the running configuration files display most passwords in plain text. Now, to encrypt all plain text passwords, use what the command called service password encryption, and which is a global configuration command. So here, after you have given all the passwords, you have enabled the secret password, you have given the line console password, and then you have also given the virtual terminal passwords. You need to encrypt the password so that anybody who finds a way to enter the system will not see the passwords as Cisco, as class, but they will see it as encrypted. So after you have done all that, the next command you have to give the switch is service password encryption, and then exit. When you do that, the passwords, the line console password, will change from the Cisco you give to these strings of what? Numbers and letters. Then the virtual terminal password will also change from the class or the Cisco you gave to these numbers, so that nobody can intercept the password in the communication medium and use it to compromise your system. We also have what we call a banner or banner messages. We all know that a banner is a display of very important messages for people to read. In the same vein, if anybody enters your network, either through your router or your switch, you can provide a banner of information for that person, so that those information can be warning of unauthorized users, or can be given a particular instruction as to what whoever has entered the system must or must not do. So a banner message is an important way of warning unauthorized personnel from attempting to access the device. Now, to create a banner message or we call it the banner message of the day, on a network device use banner MOTD. So the banner MOTD is the command, and the MOTD is simply message of the day, and then it is followed by the hash sign. So the message of the day is kept in between two hash signs and at the global configuration mode. Now note that this hash in the command syntax is called the delimiting character. It is entered before and after the message. So here the command banner MOTD, then you bring the hash sign and then you give the message of the day, which is unauthorized or authorized access only, and then you end it with another hash sign. So the banner will display on attempt to access the device as this way: unauthorized access, user access verification, then it will ask you for a password. So these are some of the securities we put on our switches and our routers to warn of what unauthorized users, and one of them is the banner messages we call the message of the day. Now, when all these configurations have been done, you need to save the configurations. There are two system files that store the device configuration. We call one the startup configuration file. The second one is the running configuration. And we want to know what the startup configuration is. Now, this is the saved configuration file that is stored in the NVRAM. What the NVRAM is simply non-volatile RAM. Now, it contains all the commands that will be used by the device upon startup or reboot. Now, flash does not lose its contents when the device is powered off. So the startup configuration are saved or are configurations that are stored on a non-volatile RAM in the switch or in the router. Now, these commands, or it contains all the commands that will be used by the device upon startup and reboot. And then we also have the running configurations. Now, these running configurations are stored in the random access memory or the RAM. Now, it reflects the current configuration. It modifies the running configuration, or modifying the running configuration affects the operations of the Cisco device immediately. So RAM is volatile memory. It loses all its content when the device is powered off or restarted. So RAM is volatile, but the NVRAM is non-volatile, which we call the permanent storage. So to save changes made to the running configurations to the startup configuration file, use the copy running configuration to startup configuration privilege executable mode command. So a command called copy run start is used to save changes that are made to running configurations to startup configuration. So on a router, you can use the command show running configurations. It will tell you the version of the router. It will tell you there are no locks. It will tell you the debug date time, and it will tell you whether the system has passwords encryption or not. So what has been done, or what the configurations that have been done on the router, if you want to know them, you use the show running configuration. And then if you want to know the startup configuration, which are in the NVRAM, you do the show startup configuration, and it will give you what is on the switch or the router. Now, to alter the running configuration, if changes made to the running configuration do not have the desired effect and the running configuration has not yet been saved, you can restore the device to its previous configuration. To do this, you can remove the changed commands individually. So reload the device using the reload command in privileged executable mode. Now this will cause the device to briefly go offline, loading to network or leading to network downtime. Now, if the desired changes were saved to the startup configuration, it may be necessary to clear all the configurations using the erase startup configuration. Now, if the things that have been stored have not been saved and you want to bring it to the router, you do reload. Reload is simply like restarting the device, and it will clear all the things that have not really been saved onto the NVRAM. But if the changes or the undesired changes have been saved to the startup configuration, it may be necessary to clear all the configurations, and the command is erase startup configuration. And when that command is activated, it will start erasing the file systems and it will remove the configurations that are undesired but has been written onto the startup configuration. Now, configurations or configuration files can be saved and archived to a text document. Step 1, you have to open the terminal emulation software such as the POTI or the Tera10 that is already connected to a switch. And then you enable login on the Tera10. So in the POTI, you have login. So you enable login on the terminal software and assign a name and file located to save the log file. Now, the figure displays that all session output will be captured to the specified my switch logs. So you give a particular folder and you say that all logs, and logs are the number of times people get in and out of the system. It will create that information in a folder which you set on the terminal emulation software. Now, if you want to capture configuration to a text file, you have to execute the show running configuration or show startup command at the privileged mode prompt. Now the text displayed in the terminal window will be placed into the chosen file. So when you do the show command for a particular running configuration, for using the terminal emulation software, you can provide a particular folder where all these show command display will also be kept. And then step 4, you disable login on the terminal software. Now the figure shows how to disable login by choosing the non-session login. So here, if you choose the non-session, it means that all the logins will not be what? Will not be saved or kept in a folder for you. But if you choose all session output, then it's going to give you the output of all the sessions, the login sessions that have been done. Now the text files created can be used as a record of how the device is currently implemented. Now, the file could require editing before being used to restore or save configuration to a device. Now, next discussion are on ports and addresses. Now, the use of IP address is the primary means of enabling devices to locate one another and establish end-to-end communication in the internet. I told you earlier in our discussions that the internet protocol addresses are logical addresses that are given to hosts and nodes on a computer network to uniquely identify them. So the structure of an IP address is called the dotted decimal notation and is represented by 4 decimal numbers between 0 and 255. And this will be explained later or subsequently. An IP address or IP version 4 subnet mask is a 32-bit long address that differentiates the network portions of the address from the host portions. Coupled with the IP version 4 address, the subnet mask determines to which subnet the device is a member. Yes. The default gateway address is the IP address of the router that the host will use to access remote networks, including the internet. So here, your TCP IP properties on your computer gives you the ability to open IP addresses automatically, which we call the dynamic host configuration protocol, or you use a static IP addressing, and it gives you the space to provide all these IPs. And subsequently, we will learn the reason why. And an IP version 4 address is separated by periods or dotted decimals. These are the dots. And we say that it's a 32-bit long address. And when we say it's a 32-bit long address, it means that when you convert this decimal into binaries, right, you have 8 bits for this conversion. You have 8 bits for this octet conversion. You have 8 bits here and you have 8 bits here. So when you calculate the binary representation of these decimals, you are going to have 32 bits for a complete IP address, and subsequently we will learn more. And then the subnet mask of each IP address resolves with the IP to show which class of IP it is. And then the default gateway address is the address which are given to all other hosts on the network to be able to enter a particular network. So an IP version 4 subnet mask is a 32-bit long value that differentiates the network portion of the address from the host portion. Coupled with the IP version 4 address, the subnet mask determines to which subnet the device is a member. So the default gateway address is the IP address of the router that the host will use to access remote networks, including the internet. We also have the IP version 6 address that are 128 bits in length and is written as a string of hexadecimal values. Now each 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. Groups of 4 hexadecimal digits are separated by a colon. So these are hexadecimal values. So each group of 4 is separated by a column. So IP version 6 addresses are not case sensitive and can be written in either lowercase or uppercase. You have to note that IP in this course refers to both IP version 4 and IP version 6 protocols. IP version 6 is the most recent version of the IP and is replacing the more common IP version 4. Now I want to look at network interfaces and ports. Network communications depend on end user device interfaces, network device interfaces, and the cables that connect them. Now, types of network media include the twisted pair copper cable, the fiber optic cables, the coaxial cables, or wireless. And I think this was duly explained in our previous video. Different types of network media have different features and benefits. Some of the differences between various types of media include the distance the media can successfully carry a signal, and then the environment in which the media is to be installed, the amount of data and the speed at which it must be transmitted, and the cost of the media and installation. So we want to talk about manual Internet Protocol address configuration for end devices. Now, end devices in the network need an IP address in order to communicate with other devices on the network. IP version 4 address information can be entered into the device manually or automatically by using what we call the dynamic host configuration protocol, which we shorten as dhcp. To manually configure an IP version 4 address on Windows PC, open the control panel, go to Network Sharing Center, change adapter settings, and choose the adapter. Now, next right click and select Properties to display the local area network connection properties. Next, click Properties to open the Internet Protocol version 4, and then configure the IP address and subnet mask information, then the default gateway. Now, dhcp enables automatic IP version 4 address configurations for every end device that is dhcp enabled. Now, end devices are typically by default using dhcp for automatic IP version 4 address configurations. Now, to configure dhcp on a Windows PC, open the control panel, go to Network Sharing Center, go select Properties, and then select Local Area Connection Properties, and then click on Properties to open the Internet Protocol version 4, and then obtain an IP address automatically and obtain the DNS server address automatically. Note that Internet Protocol version 6 uses dhcp version 6 and the stateless address auto configuration for dynamic address allocation. Now we have what we call the switch virtual interface. If we want to configure a switch virtual interface, you need to give an IP address and a subnet mask in order to be able to access the switch remotely. on the switch virtual interface. So to configure the SVI on a switch, enter the interface VLAN1 command in global configuration mode. Now next, assign an IP version 4 address using the IP address subnet mask command. Finally, enable the virtual interface using the no shutdown command. So at this mode, when you do configure terminal or config T, you do interface VLAN 1. Then you provide an IP address. Yes. So you provide the IP address 192.168.1.20. Don't be afraid with the IPs I'm providing. With this subnet mask, and you do the no shutdown command. Now the no shutdown or the no shut command enables you or the device to keep the configurations working. So it activates the particular interface for it to come up and leave the down state. Now, to verify connectivity, so you have model practice quizzes, and you have packet tracer activities we will do together. And in that packet tracer activity, you configure host names, IP addresses, and on 2 switches. You use the Cisco IOS commands to specify or limit access to device configurations. You use IOS commands to save the running configurations, and you configure 2 host devices with IP addresses, and then you verify connectivity between 2 PCs. So what have we learned today? We have learned that all end devices and network devices require an operating system. And then we have also learned that the Cisco IOS software separates management access into the following 2 command modes: the user executable mode and the privileged mode. We have also discussed global configuration mode as accessed before other specific configuration modes. And then from global config mode, the user can enter different sub-configuration modes. Now, each Internet Network Operating System command has a special format or syntax and can only be executed in that appropriate mode. We have also learned that basic device configurations like host name, password, encrypt password, and banner are essential. And then we have also known that there are 2 system files that store the device configurations. We have the startup configuration and then the running configuration. We have also learned that IP addresses enable devices to locate each other and establish end-to-end communication in the internet or on the internet. Each of these devices or each end device on the network must be configured with an IP address. Thank you so much. God bless you, and stay tuned for our next video.